All right, guys. Here are more examples of from section 3.4 applications of position, displacement, velocity, and acceleration. Okay, so this one says example 4, but technically it should be example 5. Okay, let's see. Did we already have? Yeah, because this is already example 4, right? Did I count it right? I just want to go back and double check. Yeah. So I have 2 example 4. So if it's not already fixed, please fix that to example 5. But no worries, it's not important. Okay. The equations for free fall near the surfaces of Mars and Jupiter, S in meters, and T is measured in seconds. Okay, so S is measured in meters and T is measured in seconds, are following. Mars, S equals 1.86 T squared, and Jupiter, S equals 11.44 T squared. How long would it take a rock falling from rest to reach a velocity of 16.6 meters per second, which is about 60 kilometers per hour on each planet? Okay, so this one is asking from each planet. So what we would like to do is kind of organize this in a way that we are going to calculate Mars over here, and we will calculate Jupiter over here. How long is asking for time, so I would need to solve for T. So on Mars, your equation in terms of T is the position is S equals 1.86 T squared. On Jupiter, the position is 11.44 T squared. Okay. They gave you the velocity. Velocity is given to you as 16.6 meters for every second. So velocity is already given. So velocity is 16.6 meter for each second. And it's giving to us both the same. So 16.6 meters per second. Okay. So what we would like to do now is we are going to look for T. Well, velocity, as you know by now, is the derivative of position. Okay, so S prime is 1.86 times 2t. So that's gonna be S prime equals 1.86 times 2 is now 3.72 t. Okay, well, remember velocity is S prime, so these two are now going to be the same. So I'm going to set them equal to one another. 16.6 equals 3.72 t. Divide both sides by 3.72. 3.72. So time on Mars, okay, time on Mars is 4.46 seconds. Okay. So they gave you velocity already. So this type of question really wants to know, hey, do you know the relationship between velocity and position? So because they gave you velocity and it wants time, how long would it take a rock falling from rest to reach a velocity of 16.6? So now we're just solving for time by taking the derivative of S, putting it equal to 16.6 and solve for T. Similarly, we are now going over here and do the same thing. Okay, S prime is 11.44 times 2t. So this is going to tell me that S prime equals 22.8 t. I will now take these two things and set them equal to one another. 16.6 equals 22.88, I should say. This one should be 88, okay? And then times t. Divide both sides by 22.88. 22.88. So t is going to come out to be 0.73 seconds. Okay, so it looks like on Jupiter it's going to reach a velocity of 16.6 meter per second a lot faster than on Mars. Okay, so let's just write down our final answer. It will take about 4.46 seconds on Mars and 0.73 seconds on Jupiter to reach a velocity of 16.6 meters per second. Okay, it's an apply problem, so what normally I would like for you to do is to write out a full sentence or sentences to answer this apply question. Okay, and this is the conclusion of example 5.